Hi kiddos, this is Miss Stark with another video. This time we will be doing Unit 1 review. So the first things I always do is go to the upper right hand corner and write my name. Okay, I'm going to zoom out a little bit so I can see all of problem number 1. Problem number 1 says, figure F is a rotation of figure C. Choose the corresponding line segments of figure C for each line segment of figure F. When they say corresponding, they are meaning same side. So since these two figures are the same figure, just rotated, we need to find which side is the corresponding of F and C. So the first one they give us is G and F. G and H. So we have our options of QP, ST, SR, and TP. So we have that to go with. So we have GH, which is 1, 2, 3, 4 units long. I have QP, so let's see, QP is 1, 2, 3. Nope, can't be QP. I have ST, which is 1, 2, 3, 4. Okay, it might be ST. I'm going to leave a little mark there so I know. SR, no, it's not a straight line and it's not nearly long enough. And TP, nope. It's going at an angle and it's only, yeah, it's not long enough. So my answer is ST. So I know ST will not be an option going down because only one side can be an option for each side. Now if GH appeared again, then yes, it could be. But as you see, I have GK and not GH. Okay, next one is HI. Looks like it's 2 down and 1 across. So let's see. QP, 1, 2, nope, it's too long. SR, 1 and 1, nope. And TP, 2 and 1, yep. Now if I look at GH and HI, they both have H. So if we were to look at that, I have ST and SR and TP. So it would have been either SR or TP because they share a letter. Next, JI. So if we were looking over here, we would know it had a P. Our only option is QP, but let's make sure. JI is 1, 2, 3, and QP is 1, 2, 3. Yep. Okay, now we have G and K. So we know T is corresponding with H, so S must be corresponding with G, so it must be SR, but let's make sure. We have G and K. G is with this H, not this H line, this 4 unit line, so it's either RQ or RS. RQ is not an option, but let's make sure. 1, 2, 3, 4. Yep, it's SR. Okay. Down to number 2. Choose angles with the same measurement as angle E. Choose all the correct answers. When they give you that option, choose all the correct answers, it usually gives you the hint, hey, there's more than one possibility. So we have all these different triangles. We want the same measurement as E, so that means the triangle must be the same as triangle D, E, and F. So D and F is 2, and D and E is 3. So we're going to look for triangles with a length of 3 and a length of 2. So if we were to look at A, B, and C, they have 3 and 2. So this is a possibility. GHI, we have 2 and 4. so this would not be a possibility. M and L, we have 3 and 3, so this one is not a possibility. And we have PQR, which is 3 and 2, so this is a possibility. So knowing that angles from HGI and MNL are not a possibility, we can cross out C and D. Now we know an angle here is a possibility, and the only option they gave us was P. So now we just need to figure out from this triangle if it's angle B or angle C. Well, lucky for us, the triangle they gave us for A, B, and C looks like a translation of D, E, F. So we're looking for the one that has the 3 and then the 3, 2. So here's 3, 3, 2, so it's possibly B, 2, 2. No, it can't be C. So my answer is B. Okay, scrolling on up to number 3. We have, does figure B appear to be a rigid transformation of figure A? Use parallel sides to explain your answer, your reasoning. So what they mean by rigor is they are the same side. There is no dilation. So what we're going to do is, it says to use the parallel sides. The parallel sides are the two sides that will never touch, two lines that will never touch no matter how far they go. For B, that will be this one and this one. For A, it would be this one and this one. Now, if we were to look at these two parallel sides, we would see letter B is 3 units apart, while letter A is 2 units apart. So I'm going to write it out. You can type this out, but for me it's easier to write at this moment. So my answer would be no. They are not a rigid transformation. Because the parallel sides of figure A are 2 units apart, while figure B's are 3 units apart. And the reason why we're using the parallel sides is because it said right here, use parallel sides to explain your reasoning. If we didn't explain the reasoning and we just put no, they are not rigid transformation, we would not get credit, or possibly only get half credit because of this. So figure R is congruent to R prime prime prime. So congruent means the same size, and this is the symbol we use to show that, as opposed to writing out congruency. We need to describe a sequence of 3 transformations that can be performed on figure R to show this. show your work. So showing my work would be actually doing the transformations that I write down. So what I'm going to do is, I know from the point being over here to the right as opposed to the left, I'm going to need to reflect it. I need 3 transformations. So I'll probably rotate it and then translate it as opposed to just reflect and translate, because I need 3. I could just reflect and then move it, but it wants me to rotate it probably because it needs 3 different transformations, and I can't make it any bigger or smaller because they're the same size. So my first one, like I said, is going to be reflecting. I'm going to reflect here over the x-axis, because the y I don't think will help me too much. So what I'm going to do is I'm going to reflect over the x-axis, which means all my points need to be the same distance away from the x-axis up here. So this point is 1, 2, 3, 1, 1, 2, 3, 4, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, gonna connect the dots. Okay, and I'm gonna label this R prime, because this is my first transformation, reflecting over the x-axis. Next, I'm gonna rotate. I'm gonna leave translation last because that's my easiest one. Let's see. If I rotate it, I'm gonna rotate it over this location, which is called my origin. And when I rotate over the origin, what I end up doing is flipping my x and my y. So instead of 3 and 4, I'm going to do 4 and 3. Instead of 3 and 6, I'm going to do 6 and 3. Instead of 6 and 4, I'm going to do 4 and 6. Instead of 7 and 6, I'm going to do 6 and 7. Connecting my dots. Labeling this R prime prime because it's my second transformation. Then I translate. I move the points. So it looks like I go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 5 down. So here's where I would write what I did. So I reflected, if I could spell right, reflected R over the x-axis. You always, when you're rotating and reflecting, you want to put where you're reflecting or rotating from. So for here, it would be over the x-axis. Then rotated 90 degrees clockwise round the origin. And then, in a hard time spelling today, then translated five units down. Okay, so notice how I wrote translated instead of moved. I also put rotated clockwise because if we were to look at a clock, it's going this way, and that's what we did. We rotated that way. And the origin is what we call 0, 0. Point 0, 0 is called the origin. That's why it looks like it's a 0, but it could be an O as well for origin. Just realize that sometimes you'll see origin, which means the center where the two axes meet. Okay? And I use translate instead of move because if we ended up with a problem and they were telling us which steps to take, it would say translate instead of move. Okay? Number 5. Triangle DEF is congruent to triangle LMN. Which sequence of transformations can be performed on DEF to show this? So let's read what they have so far. We have reflect DEF over the y-axis, then translate the image 6 units up. So we can do that. Reflect over the y-axis, so here this is the y. So each point is going to be the same across the y-axis. So we're going to have this. One, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4, 5. Okay. Connect my points so I see the shape better. And then move 6 up. Well, if I were to move just this image, it wouldn't be the same because as you see, it's a reflection of this over the x-axis. So A cannot be my answer. Okay, I'm going to erase this triangle. Okay. Translate DEF 6 up, then rotate counterclockwise 90 degrees around the origin. So 6 up, so I move every shape 6 up. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Let's connect them. Okay, so far it looks good. Because I'm going to rotate it 90 degrees counterclockwise, that means I'm going to go the opposite way of a clock. So again, the way I rotate around the origin is instead of 1 and 2, it would be 2 and 1. Instead of 1 and 4, it'd be 4 and 1. Instead of 5 and 4, it'd be 4 and 5. So right now my points aren't lining up, so I know this is not correct. It looks so good though, but I'm glad I tried it out just to see if it was correct or not. So B is out of the question. So we're going to rotate 90 degrees clockwise and then rotate it again, it looks like. All about the origin. So remember, rotation means we flip the x and the y. So instead of 1 and 2, we're going to have 2 and 1. Instead of 1 and 4, we're going to have 4 and 1. Instead of 5 and 2, we're going to have 2 and 5. Connecting my dots. Okay, since I'm rotating again, I have to do the same thing. So instead of 2 and 1, I have 1 and 2. So far we're starting off good. Instead of 4 and 1, I'm going to have 1 and 4. Looking good, looking good. Instead of 2 and 5, I'm going to have 5 and 2. So as you see, my points line up exactly. So I know that C is probably going to be my answer. I still have one more to go. I'm going to test it out just to see. Translate 6 to the left, then rotate clockwise. Okay, 6 to the left. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. Okay, next we rotate it clockwise. Yeah, clockwise. So that means, remember, that rotating about the origin, only about the origin, means we switch the x and the y. So instead of 1 and 2, we have 2 and 1. Instead of 5 and 2, we have 2 and 5. Instead of 5 and 4, we have 4 and 5. So it looks like from here, it looks like C is my correct answer for sure. And I'm just going to redraw that. I'm going to do it in a different color just so just to kind of show my work. Let's see, so we had 2 and 1. Oh, not a circle. On a line. There we go. Okay. Number 6. Sarah draws figure EFGH in the coordinates plane. She rotates figure EFGH 90 degrees clockwise on the vertex E to form image EF prime G prime H prime. Draw image EF prime G prime H prime. So right here, I know that E is going to stay the same. No matter what happens, my E is the same. So my other line should still radiate from this point. So I'm going clockwise 90 degrees. So my easiest line to do is this straight line, because I know 90 degrees, it's still going to be a straight line. And I know it's 1, 2, 3 down. 1, 2, 3. And this one would be H. Now, G. From H, G is 1, 2. I'm not going to go this way because that's not how G goes. If I were to rotate it, G would go down. So down 2. And this is G prime. K, F is 2 from G, and it's going the same direction as H to E, so it's right here. And just to make sure, F is 2 and 1, or 2 and 1, so 2 and 1. Yep. Okay, gonna draw my figure. And there we go. And I know this shape is correct because if I were to rotate it, it would look just like my original shape. If I ended up with the shape being over here instead, I knew something would be wrong. Just because I know this shape would have to be reflected somehow. So here is my figure with my labeled points as well. Now our last one, number 7. Triangle PQR has vertices P negative 4, 4, Q negative 2, 3, and R negative 5, 2. Triangle PQR is rotated 90 degrees clockwise about the origin. Then the image is translated 5 units down and reflected across the y-axis. Where are the coordinates of triangle P prime prime prime, Q prime prime prime, R prime prime prime? Show my work. So, what I'm going to do is rotate it 90 degrees. Just take it one step at a time. Our first step is to rotate it 90 degrees along the origin. Luckily, it's by the origin, so all I do is I flip-flop my X and my Y. So instead of 4 and 4, I'm still going to have 4 and 4. So that one's kind of easy. Instead of 2 and 3, I'm going to have 3 and 2. So 3 and 2. Instead of 5 and 2, I'm going to have 2 and 5. So there is my first transformation. Next up, I have to translate 5 units down. So that means I have to move the image, each point down 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Then I connect the dots. My last one says reflect over the y-axis. So reflecting over the y-axis means all the points are going to be the same distance from the y-axis and in the same area. So I'm not going to move this up or down, it's just going to be moved to the left or right. In this case, it's moved to the left. So 1, 2 away from the y, so 1, 2 away from the y. One, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. So now I need to write what my coordinates are for P, Q, and R. But I flipped it so many times I don't remember which one's which. It's moved around so many times. So what I'm going to do is I'm going to mark each one on each figure. So P was 4 and 4. So I look for 4 and 4. So this is P. Q was 2 and 3. So I'm looking for 3 and 2. 3 and 2. Here's Q. So this is R, 5 and 2. 2 and 5. Yep. Okay. So luckily this one's easy. We just move them all down one. Okay, and reflection. So this is a reflection of Q. This is a reflection of R. And this is a reflection of P. So knowing that, I know that P prime 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 is over -4 and down -1. Okay, Q prime 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 is over -3 and down -3. And finally R is over -2 and down 0. I hope this video has helped. If you have any questions, let me know. And I can't wait to see you next time. Bye!